So the random variable x can be approximated by a binomial distribution where n is 50 and p is 0.4. It's asking us to find the largest value of k such that probability of x being less than or equal to k is less than 0.05. So if I wanted to draw this on a number line, that's our starting point. It would be 0 going all the way up to a certain number, but 50 is right at the end. But what number am I interested in? K. And it's saying everything less than or equal to k, i.e. this bit. And what is that probability? Probability of x being less than or equal to k, they're saying is less than 0.05. Now, what's the issue with using the calculator on this? Yeah, and what's the calculator input? The calculator requires you to input. So calc input are what? It requires you to write down n, x, which is essentially that k value here, isn't it? And p. Although we know what n and p are, we don't know what x is. So calculator, unless you do trial and error, which could take you quite a while, because it goes up to 50. Where do we start from? Where do we go to? So this is where the calculator is probably not going to be the tool that you go to in this case. Here you rely on the table, because the table has all the numbers there, so you can see it. But so how do we use the table for this particular case? Well, let's take a look at how we're going to use this. I'll minimize this. So I know what I'm looking at. I'm looking at a value of x where the probability becomes less than 0.05, when it starts being less than 0.05. What table am I looking at? My table needs to have what as my parameters? 50. Yeah, so let me write down the binomial that I'm looking at. And remember, this is question 7 I'm looking at. So the binomial distribution, I'll write it out. X is approximated by the... So calculator doesn't work here. We're going to use x is approximated by binomial distribution 50, 0.40. Let's go and find the table that has n as 50. So you go down, n is increasing as you go down the pages. As you can see, it starts jumping from 25 to 30, and then it goes to 40, and then it actually jumps to 50. So it doesn't have all n values on the table, whereas calculator, you can use any n values. So if a question like this comes up in the exam, it will be a value of n that's already on the table, if it requires you to use the table. It won't just give you any random one, okay? So we found n is 50, there it is, and the probability here is 0.4. And that's also a probability that's given in the table. If the probability was 0.36, you can't use the table because that's not on that top, as you can see here. So we now know what to use, the correct table. We know which column we're looking at, 0.40. What we need to do is we need to look down this column to see when that probability is 0.05. Let's try and find the number closest to 0.05 first. So I'll go down my table, and I'm looking for where it's 0.05. Can you see here? 0.0, you can't? You can? Oh, brilliant. Someone's got really good eyesight. So I'm looking at this bit here. Okay. 0.057. Is that more? Is that less than 0? What is this actually showing? This is showing when our probability becomes less than 0.05. So at the moment, this 0.057 is actually, is it? The 0.057 is, oh, it's got 2 zeros, sorry. I need to go down a bit further. 0.0280, 0.0540. What is this? It's more than, but what do we want our probability to be? Less than it. So it's not that one. We are interested in that one just before it. Okay. And what we after? It's x value. So which side do we need to look at on the table? Yeah. So we zoom out, look to the left. What is the x value associated with this? 13. So then we can go and write down using tables, and you'd write down using binomial CD table. Probability of x less than or equal to 13 is equal to 0.0280. Probability of, I'm going to write down the one after it as well. Probability of x less than or equal to 14 was 0.0540. Yeah, I've done my table. I'm going to focus on answering the question. I'm interested in the x value that gives me a probability which is less than 0.05. This one, no. This one does. 12, 11, and so on will also work, but we're looking for, what does it say? Can you see what the question says? The largest value of x that gets us a probability that's less than 0.05. So I could have used 13, 12, 11, 10, 9, but it actually specifies it wants the largest value. So that's why we know to look at that. So you always look for the 0.05 first or something close. And I would always write down a couple of them next to each other, just like I've done here. And then I'd worry about answering the question. Do I want the one before it or do I want the other one after it? I'm not sure which side. I'll focus more on the question now along with these two answers to answer that. Whereas if you're trying to go back between your question and the table all the time, it's going to be a bit confusing. So write down your answers and then focus on it. So then we've picked the appropriate one. Then we can say k equals 13. Okay. We'll look at one more, part B, which is a bit interesting because this is, can you see which side it's looking at? The more than side. So it's not looking at the left-hand side, it's looking at the right-hand side. But the table doesn't give you the right-hand side. Okay, so there's the added difficulty. So it's all about that number line. If you can draw the number line and know where you're working at, you will be fine. So same question. I'm going to keep the same number line. Let me just go and write this out underneath here. Let's take that a bit further. Do part B here. So now I'm looking at part B of that same question, 7, part B. Again, number line 0 all the way up to a value here, which is R. Now notice here, this also doesn't have the equal sign in it. So we need to think about the numbers before and after R. What are the numbers before and after R? R minus 1 and R plus 1. All the way dot to 50. Do you understand? So we are interested in everything greater than R. Probability of x greater than R, which is what? From where to where?
1, 0 to R, minus 1, from there to
greater than. Probability of x being greater than R.
yeah.
So from which one to where? R plus 1 all the way to? That's what we're interested in. But the calculator or the table doesn't do the right-hand side, does it? It only does the left-hand side. So the first thing is the number line. Without the number line, you're going to get things wrong. You're going to either go from R or R minus 1. You'll get things mixed up. Start off with your number line. So we are after this. Should write down here. Probability of x greater than R is less than 0.01. What R value are we looking at? But the calculator won't do that. Instead, we're going to focus on probability of x being, what is this side? How would I write this out? Less than or equal to R. If we want that probability to be less than 0.01, what is this probability going to be? Greater than 1 minus 0.01. Yeah, I'll write out the working out just so you can see. It would be greater than 1 minus the other probability, which is greater than 0.99. So we are looking for what value of R will get our probability to be greater than 0.99. So we're going to go to the tables. We're going to find a probability that is close to 0.99. We're going to look at the one above it, i.e. less than 0.99, and the one after it. And then we'll come back to this to actually pick the correct thing. We won't try and do all of it in one go. It'll be a bit confusing. Okay, so I need to go and find the table that contains 50 and 0.50 as the n and the p. It's the same table that we used before. Just keep that to the side. So there we are, same table, 50 and 0.4, and I'm looking for a probability that is close to 0.99. So if we go in again, we're looking at this column here. This one's a bit lower than 0.99, and this one is greater than. So it's going to be either one of these two, right? One's lower, one's greater. So I'm going to focus on these two. So we said it's either this one. So let's write that down. 0.9840 for what value? And 0.9924. I'm going to write down what the x values were for those. So that was for 27 and 28. So this is probability of x less than or equal to 27. And this is probability of x less than or equal to 28. I've written that down. Get rid of my table. Back to my question. Let's focus on this a bit more. What do I want? Look at that word as well. Can you see the word? Smallest. What is the smallest number such that the probability is less than 0.01? Yeah. But although this is the less than 0.01 is the non-calc side, we can't get that. We need to work with our side, the left-hand side, which is the calculator and the table side. We're looking for a value of R where the probability becomes greater than 0.99. So is it this first one? No, not interested in that one. This is the one that gets us a probability of 0.9924. So what can I say then? If I'm comparing this to that, which I am, what can I say my R value is here? Very good. Look at that. There's my R value and there's my R value. That gives us a probability greater than 0.99. So I can say here R is equal to 28. I haven't answered the question yet. All I've done is I found out what R is. Do you see our number line? What we've got? There. There's the R value there. That value here is 28. I can write that down here if it helps, 28. So this must be 29. The question's asking us, this was the question. This came from the question, as you can see here. That's my question. It's asking us to find the value of R. So what is that value of R? Well, is that R the same R here? It is, isn't it? So what is my R value? We can say R is equal to 28. I've answered it correctly. Okay. Sometimes it might be you have to write down 29, depending on the question. It might be asking for R plus 1 or etc. Yeah. So you need to really think about what you're answering when you look at the question. So a clear number line, and all our working out that we do using the calculator, can you see the table is all on the left hand side, because that's what the calculator and table does. The right hand side is what you then figure out afterwards.